This tutorial video is going to be about significant figures. Significant figures are numbers and how you round numbers or how you present numbers that represent how accurate your measurement was. So for example, in a lab experiment where you are measuring the mass of something, you might have a scale that can measure all the way to the thousandth place, in this case 2.034 grams. Or you might have a scale that only rounds to the ones place. Which one of these scales do you think is more accurate? I think everyone is going to recognize that the scale that can measure to the thousandth place, 2.034, is more accurate. And so when we work with numbers, we want to show how accurate that number is. And so when I present the number 2.034, that my fellow scientists or my audience is going to recognize that that was a much more precise measurement than the 2 grams. So this is why we in science care about significant figures. Your measurements can only be as precise as the instruments that you use to measure them. And so we want to reflect that in the numbers so that when people are looking at our data, they can sort of recognize with how much accuracy our numbers are. So there are a couple of rules of how we identify significant figures and how we round our answers. So first of all, I need to remind you that when I'm talking about whole numbers, those are the digits numbers 1 through number 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9 are called whole numbers. All whole numbers are significant. We actually count them, okay? Then you have 0. If you have the zeros either count as significant numbers or they don't count. And the general rule, this is sort of the shortcut to significant figures, is if the 0 is after a whole number and the number includes a decimal, it's significant. It has to have both of those things. The 0 has to be after a whole number, so a number 1 through 9, and the number has to include a decimal. The 0 is not significant if it's before a whole number, even if there is a decimal. Okay, so zeros before a whole number don't count. Zeros after a whole number do count, but they have to have a decimal in them. So let's give you us a couple of examples. All right, so all numbers that are whole numbers are significant. So in example number 4, 1.456, these are all whole numbers. I would say I have 4 significant figures, and that means when I use this number in my calculation, I need to make certain that my answer also has 4 significant figures. The second one has 2 significant figures. That would mean that when I use this number in my calculation, I need to make certain that I round my number to 2 significant figures. And lastly, I have number 3 being just 1 significant figure. That means I need to round my number just to 1 significant figure. Rule number 2 discusses the zeros. So any 0 after a whole number, if the number includes a decimal, are significant. So you'll notice that I have 3 numbers here. My apologies that they're all labeled number 1. So let me go through the second slide one more time. I'm having a little bit of an issue with my screencast-o-matic. Just making certain that I had worked through this here. So remember, for rule number 2, zeros after the whole number, if the number includes a decimal, are significant. So for this first one, you're going to see that that in this situation, we have here the zeros after the 3. That's a whole number, and so you would say you have 4 sig figs. For this second one, you have again, a 0 after the whole number. It's okay that the 0 was before the decimal. As long as the number has a decimal, it is included. So this number has 3 sig figs. And then lastly, we have this number, 3.0800. We have all those zeros being after a whole number. This number would be considered to have 5 sig figs. Rule number 3 was talking about zeros before a whole number are not significant, even if there is a decimal. So this number 0 is not considered significant. This 0 is not significant, nor is a third one. So this number has 2 significant figures. That doesn't mean that we want to get rid of the zeros. It just means that when we're actually calculating an answer, we want to represent something that has, we want to round our answer just to 2 significant figures. And in this situation over here, keep in mind these are just numbers that the numbering system has gone off. That here I have 2 significant figures again, and the reason is that that 0 is before a whole number. All right, now for this third one, we have these zeros being before the whole number, so they are not significant. We don't count them. But these zeros are after a whole number and there's a decimal. So in this case, this number has 3 significant figures. That's the same case for this here. These first 2 zeros are not significant because they're before a whole number, but these zeros are significant. So I add all my whole numbers and those zeros that are significant, and I get 4 significant figures. Now let's apply this to the situation of working with numbers. So here I have a common example that I've asked you to do in the past where you have to do a gram to mole conversion. Only the value that I give you is 24.00 grams. That means that I used a scale that could record to the 100th place. So what I want to do is identify how many significant figures I have. So this 2 counts because it's a whole number. This 4 counts because it's a whole number. Remember, this 0 counts because it's after a whole number and there's a decimal in the number. And that's the case for this 0 also. That means I need to round my answer to 4 significant figures. So I set up my dimensional analysis. I have 24.00 grams of carbon. I look at my periodic table. It's okay that I don't have my periodic table to 4 significant figures. Makes no difference. These cancel out. All right, and when I do my math, it works out to be that I have the answer of 2. Now, the problem with my answer is it doesn't represent how many significant figures I had going into the measurement. So for that reason, I'm going to put a decimal behind the 2, and I'm going to add as many zeros until I have the right number of significant figures. I needed to have 4 significant figures. By adding the decimal and adding 3 more zeros, I now have 4 significant figures. So now you never have to ask me, how should I round this number? It's always based on significant figures. Let's try one more. I have a scale, and where this measurement tells me of my carbon, I have 0.024. Now remember, these zeros are before a whole number, so they are not significant. We are going to put an X by those, okay? They don't count, but these 2 numbers here are whole numbers, and so they do count. In this case, I have 2 significant figures, okay? So with that said, when I work through my answer, let me set up my equation. I have 0.024 grams of carbon. Use my typical dimensional analysis. My answer is 0.002. Okay, so now I need to stop and check, do I have 2 significant figures? And the answer is no. Remember, this X doesn't count. This zero doesn't count. This zero doesn't count. This zero doesn't count. Right now, those zeros don't count because they're before a whole number. This 2 here does count, but I need 2 significant figures, so I just added a 0 at the end. All right, we'll do one more. Let's say I have 24.1 grams of carbon. Again, doing my dimensional analysis. All right, my answer again is 2, but I need to represent how many significant figures I have. These are 3 significant figures. So I could say 2.00 moles of carbon. That's 3 significant figures. And remember, if you need to add more, just add a decimal if there's no decimal and add the zeros, or just simply add the zeros at the end.